is learning from the data and then it's just being ready for prediction. Okay, there are multiple methods there. So that is called supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning? First of all, supervised learning means if we are giving a labeled data, through that if the that is called learning. So what is labeled data? So that is the next question, right? So like in machine learning, you can say labeled data means the human being, like we are the human intelligence, right? The human intelligence are we are creating the AI, right? Of course, it's not automatically created. We created the AIs. Okay, now we are using various kind of AIs each and every day in our day-to-day life. But before creating that, we are giving something to the computer. Like that's how we are teaching a kid. Okay, so for example, the kid doesn't know which is cycle, which is motorbike, right? So we will tell them like, okay, if the cycle is there, there will be a chain, so we have to pedal it, then it will move. So if it is a bike, there will be a engine, so we have to put a petrol, that is the fuel. So if you're just rising the accelerator, so we are teaching a kid in that way. The same way, we have to teach the model. From that, the model is learning. That is called supervised learning. Then what is unsupervised learning? So unsupervised learning will be entirely opposite. Okay, we won't teach that in that way. We will give a set of data. There is multiple different kind of data. So the model will learn that by itself, and then it will separate the things. Okay, if it is like this, if you're just showing 5 cycle image and then you are not saying anything. Okay, simply you're just giving 100 images. Okay, that is around 30 cycle images there, 30 bike images there, then 30 car images there. So if you're just giving that in unsupervised learning, it will cluster that. The cluster means if it is looking like this, it is a set of class. So in the group, this is a group. The cycle, they will make it as a group, and then it will take the bike image, it will make it as a group, and then it will take the car image, and then it will take that as a group. So from that, it will cluster that. From that, it will learn. So that is called unsupervised learning. So what is reinforcement learning? The reinforcement learning, learning through, you can see, learning through trial and error with a reward-based system. The reinforcement learning will learn from our feedback. That is the thing. So for example, we are using multiple social medias, right? For example, if we are using Instagram, so we are getting some suggestion. Even it can be a post suggestion, it can be an advertisement suggestion. So that time it will ask a question: are you interested or not interested? Like that. Okay. So when you are giving interested, so that is the algorithm is there. So that algorithm is giving you the suggestion. Okay, it is sending you the posts. If it is YouTube also, if you're just checking some same kind of genres videos and all. So for example, if it is a tech guy, he will search mostly depend on the tech. He will search some things about the technical things. So it will always suggest the technical videos. So if you are a person who is always listening songs and all, so if you're just always searching the songs, then you will get more song suggestion. How these things are happening? It's because of the reinforcement learning. Okay, so there you can, if you're just are liking that, then that will learn from that. Okay, that is a reward for that. Okay, that is a trial. So if that you are not liking that, you are disliking that, then that is the error for that. Okay, it will learn from the error, like us. Then, so I told you, first of all, when before getting into that, we have to understand difference between what is artificial intelligence, what is machine learning, and one more thing is there, that is called deep learning. So we have to understand what is what. So artificial intelligence is simply I'm saying artificial intelligence can be a final product. Okay. So engineering of making intelligent machines and programs. So it is a final output of a machine learning and deep learning concept. Okay. So if I have a machine learning model, so the model cannot be considered as a AI. Okay. It is a machine learning model because I just made that program to understand. So what I'm just trying to say. Okay. If I'm just giving some data, feeding some data, from that the machine learning is learn the things and then it's stored as a model. Okay, if the model is staying there, so it cannot be considered as a AI. So if the model is ready to predict something, so it can be a future class, it can be a classification, it can be analysis, anything. If it is doing anything, that is the AI. So it's a final product. Okay, you can say like artificial intelligence is the overview of machine learning and deep learning concept. Machine learning is learning the stuff from algorithms and methods. Deep learning is based on deep neural network. what is machine learning and what is deep learning, that we have to understand first. Then we will give the artificial intelligence. So machine learning I already showed you. There are supervised learning, unsupervised learning, and reinforcement learning. So it is an image for that I just give the example, but it is not good. But at least you can understand from that, I guess. So you can see which supervised learning, and then the person is sitting and then it is just teaching something to the robot. So it is not a robot. Actually, AI is not a robot. So if you want to make a robot, you can use the AI for that. Okay, the AI is work as a brain. Okay, anyway, all the things has to be work together. Then only you can make a robot. So, but the robot brain can be considered as a AI. Okay, so the person is trying to teach something to that. So that is learning from that. Actually, you can consider as a program or a laptop or system, anything like that. So it is just learning from that. That is supervised learning. In the unsupervised learning, you can see it is just sitting and learning from itself. Okay, so it is just finding the patterns and difference between each data. From that, it's clustering the data and then it is just learning from that. It is just making some, yeah, actually technically it is just making some errors. From the errors it's just learning the things. That is called reinforcement learning. So there are one more learning is there, we'll say like hybrid learning. Yeah, same as how we are just giving like taking a lot of hybrid things, like hybrid car means it can run with electric also, it can run with fuel also. The same way the hybrid learning will be work together with supervised learning and unsupervised learning. Okay, then I just told you. So what kind of product we can get from supervised and unsupervised learning. So in this you can see classification. I told classification will be like you will just separate the things by yourself. So you will teach the model to learn from that. Okay, you will separate. If it is a dot, you can see it is a star. It is a X kind of symbol. So these are the, we are just saying something. If it is looking like this, it is a dot. If it is looking like this, it is a star. We are labeling the data and then we are just providing that to the model. From there, if it is learning, that is called supervised learning. You can give, you can say that the example is classification. What is clustering? I already told you. It will give a lot of data, various of data. From there, it will find the patterns and similarity with each data, and then it will find the difference also. From that, it will differentiate the data, and then it will just cluster that like this. Okay, this is called supervised and unsupervised learning. So this is a main for process like main algorithm like arcPY algorithm, then k nearest neighbor algorithm, support meta machine, then regression. These are like whatever program you are going to make with machine learning, that time you have to utilize any one of these formulas there. So if you have to good in machine learning, then you should good in statistics. So statistics analysis is very important. So before getting into this, we have to learn all the things, like whatever we learned when we were kid in school. That time we had all the things. Okay, Bayes theorem, like how, like now also people can, like if I'm just talking about Pythagoras theorem, everybody will get scared. So but it's not that much complicated thing. But when we were in school, that time we felt that much complicated thing, but now it is not actually. So from like nowadays there is a lot of things are there to explain us, because now we have YouTube. If you don't know anything, like simply we are just going and learning from that. Okay, so these algorithms we have to learn first. So before getting into that, so after that we'll see. So now I talked about machine learning. In machine learning, there is supervised learning is there, unsupervised learning is there, reinforcement learning. So after that, I just told about deep learning. So before getting to that, we have to understand what is deep learning. So the deep learning is like, how to say, it is just mimicking like our human brain. Okay, so our human brain is made by neurons, right? So the connection between all the nerves are connected by neurons. So something I'm just talking about that biology things, but it's true. The thing is, all the things. If we're just touching something from our finger, so then immediately we are just feeling that through our brain, right? So how it is happening? So the data is passing through the tendons, like our neurons. The neuron is passing the signals through like a kind of electric waves. So it is just reaching our brain. Then from there we are realizing something. Okay, so we are feeling something. If you're just getting some pain, then also we are just understanding through that way only. Okay, so in our brain, if you're just thinking about something, there are a lot of neurons are meshed together. From that we are getting a making a decision. For example, if it is a decision making process, if somebody is asking you one question, so if he is just showing something like a kind of ball and like a kind of box. So if he is asking like what is this, then of course he will say it is a ball. How will you say? If there is an infant is there, the kid is just born, okay, it's a baby, okay, you are just asking, you are just showing the ball and then you are just asking that what is this, it will answer for that? Of course not. So the thing is, who taught the kid? Because now we grown up, so we learned from others, okay, others taught us like it is a ball, it is a box, we learned by ourselves, okay, then it is just stored in our brain as a memory. There also we have the neurons, the similar way the deep learning concept also working. Okay, so in deep learning, you can say it's a neural networks inspired by the structure and function of human brain. You can see. So the function is similar to our human brain. The way how we are thinking similar to that, it is also with okay. Image classification using convolutional neural networks for visual data analysis. So there are a lot of data is there. For example, if you are just getting into GIS, I told you there is some data or vector data is there, raster data is there. So what is vector data? For if I just mentioning about some points, polygons, lines, everything coming under vector data. Okay, if it is a raster data, you can consider as a image data. For example, if it is you have a satellite image, if it is just an image, then that is a raster data. If you are mocking something on the image, so for example, there is a road image is there, but there won't be any vector data. That is a image data. That is raster data. So if you're just drawing something on that road, then you are mocking that. Okay, it is road. Then that data can be considered as a vector data. Okay, so our maps and all is it's a combination of vector and raster data. Okay, so we can also do the process analysis with deep learning and machine learning concept. So here I just mentioned about CNN. There is only one thing is there in deep learning. If you're just asking about that, then of course no, there are a lot of things are there, but the CNN is very famous convolutional neural network, because if you're just going to handle with any image data, so you should prefer convolutional neural network. Okay, that is the main thing. So after that, you can see the difference between machine learning and deep learning concept. Okay, so we can see machine learning is there. So here there is an input. The input is the data. Okay, then we are going to extract the features from the data. So what is features? For example, if you have a image data. Okay, so that example consider this as a car only. So what are the features of the car? The car should have minimum 4 wheels, right? If it is a car, of course it should have minimum 4 wheels. So you can consider the fifth wheel as a stepney, so you can add it. So then the car should have some windows and the bonnet, everything should be there. So those are the features of a car. If you are giving 10 cars, then from there it will extract all the features. After that, it will send to the next process, that is classification. The classification is the process that machine is learning from that. It will learn from that, and then if you are just giving a new data, okay, new data like a car image, and then you are just asking that classifier to check it is an image or not, it will check the same features, the features are available in the new image or not. If you are giving the bike image, in the bike there is only two will be there. Okay, so somehow the wheels are there. Okay, it will consider like okay fine. So there is some checklist. Just make a checklist. It will check everything. So there should be a headlamp, then bonnet, and then windshield, four windows. Everything it will check. If everything is available there, then it will say like it is a car. If those things are not there, that is not a car. That will be the output for us. The machine learning concept is running in this way. Okay. So then what is deep learning? So you will give it the input, but the future extraction and classification will happen immediately, okay, without explicitly programmed. So it will learn from there and then it will store it. So then when you are giving the image, and then it will predict it's a car or not. So in the previous image you can see these are the networks. So you can see these are input layers. You can consider like these are any data like input images. Here also you can see simplified example it is. So those data will go to the next layer, that is a hidden layer. Here only the deep learning concept is working on. From this data, it will compare the data with all other data. You can see it will compare the data with all other data. It is just making the network here. Okay, the hidden layers. The hidden layers are like n number of hidden layers can be there in a deep learning concept. Okay, if it is a deep learning model, you can mention multiple number of hidden layer. From there, it will understand more and more. Then finally, you will get a output layer. So like this. Here you can see there are two hidden layers are there. Not as there is no limitation. Is like this. So after a certain stage, if we are just increasing the hidden layer, that may predict wrong. So we have to find the proper layer count. So through that, we can just get the best output from that. I mean, more accurate predictions you can get from that. So that is deep learning. So now the main point, we are just coming to the main things. That is artificial intelligence in GIS. So the integration of AI and GIS, like how it can be integrated. I told you the main thing which is going to connect the machine learning or deep learning concept with the GIS is data. So of course we are going to handle data. So we will say like it's a high quality. So the quality is only important. The quantity is not important. If I are just raising the question, of course the quantity also important. But if I are just giving, I told you if you are giving a 10 image of a car image, everything is like the image is like the car image can be taken from multiple angles, right? So if we are just taking only one car, okay, it's a red color car, and then you are just taking 10 pictures around that, and then you are just giving that inside a machine learning model. You are just giving that label as this is car. We are telling that the same way. If we are just going to put as a different car, like a blue color car, for example, that is a sports car, okay, blue color sports car. There will be a lot of difference will be there, right? So there is a shift red color car and the sports Ford Mustang car. They both have a lot of difference. If I just asking that, is it a car, that will get confused. I mean, that is not mandatory. It can be. It can be confused. For that, we have to give various number of data. That is the quality means it's not only about the quality, it's about the quantity also. Good number of quantity is the good quality. That's what I mean. So if I'm giving 100 image from various cars and then from various angles, and then you are just feeding that, and then you are just telling that it is a car, then if you're giving a new image, the accuracy will be more high. That's the thing. So difference between quality and quantity of data. So when we are just handling with GIS data, so what kind of things we can do? Okay, as an example is there. So the image classification for land cover mapping, object detection in satellite imagery. So there is an example for what kind of things can be done with AI in GIS. That is the image classification for land cover mapping. So we can do the land cover mapping through the object detection. We can identify the objects by in satellite imagery. So we can take the satellite imagery and then we can just do the process through AI. That's the example for that. So uses of AI in GIS. So what kind of users we will get? How GIS is predictive modeling. We can say forecasting future trends based on historical data. Weather prediction. Weather prediction is a very important. We are using that day-to-day life. Previously, when we were kid, that time we can say like that was like the accuracy was very less. We'll say sometimes we'll get holiday from school and then we won't even get rain. So those kind of prediction were there. But now, if I just having Google weather, in that we are getting the proper and accurate weather predictions. Okay, even you can get it for next month also now. Okay, so the upcoming month also you can get the predictions. Which day we may get rain, or which day it will be very sunny. Everything can be noticed. So that is for predictive modeling. So anomaly detection, identifying outlier or unusual patterns in a spatial data. Okay, if there is a disaster is happening, okay, something. If there is a mountain is there, a hill station is there is a landslide happen. Okay, so usually we will get the same satellite image. Okay, that time it will be like the same image will be there. You are continuously monitoring that. If suddenly a change is there, so we can just focus on that and then we can just find what's happened there. Okay, that is you can say like anomaly detection. Route optimization. I already gave an examination. So as an example for that, So finding the most efficient path for navigation or logistics. Okay. So in run time, so like the real time, actually we can just get the proper traffic data from Google Map. Okay, so which area, like if you while going also will get the color is keep changing. It can be in orange, blue, sometimes red. If it is a high traffic area, it will be completely red. Those things will be there, right? So these kind of things, though, like it is just optimizing the route, and then we are just it is just suggesting us to go through a different way, right? Usually we used to go to the same way, but suddenly it will ask us to go in a different way. If something happened there, if something an accident or something like that, so anything happens, there will be a traffic jam. So that time it will suggest us to go through a different way. So that is route optimization. This is also like happening by the GIS data. Okay, so the next one, what is geospatial data? I told you. So whatever machine learning model or deep learning model we are going to create, the data is very important. It should be a quality. The quality and quantity should be in a very good manner. So then only we can just utilize that, and then we can create any AI or models. So that time, what kind of geospatial data set we can take? So important of data quality, you can see the accuracy, completeness, and consistency in geospatial data sets are crucial. That is very important. So if we are just giving an image, the image should not contain any wrong data. If it contains any data, that time it will give us wrong predictions. Then you can see the type of data set. What kind of data set you will get from like vector data? I told you vector and data raster data are the important data sets in GIS. The vector data is points, lines, and polygons. Those are vector data, and raster data is grid of cells. Grid of cells means the pixel image. So all the image, whatever we are having, so everything is made by pixel, right? So we are just giving some. If we are just buying a mobile, then also we are just getting 64 megapixel camera, 108 megapixel camera. So we're just going like this. It went more than 200 nowadays. Okay, all the images are like defined by the pixels. Okay, if we are just converting the, yeah, we are always using the images or 2D images only. So the 2D images are contains pixels. The each pixels will contain RGB value, the red, green, blue value. Okay, so it's a kind of square. Each square has the color values. From that only we are just showing the image, and then we are just seeing that. From that only we are just getting the data. That is called raster data. Okay, so before that we will see geospatial data set. Okay, we'll see what kind of libraries we will use geospatial analysis. What is why we are just talking about analysis now? So we got into AI and machine learning. Now the guy is talking about analysis. So what is the like similar, like what is the connection between analysis and other artificial intelligence? That is the main thing. So I told you, when whatever data we are getting that, so immediately we can't use the data for learning. We have to process the data. If we have to process the data, first of all we have to analyze the data. From that we have to find the problems and what are the errors are there in the data. We have to fix that. Then we have to make a proper data set. Then only we can just give that as a label data for learning. Okay, if you're just having some wrong data set, then the whatever making models, like for example it is a machine learning model or a deep learning model, anything like that, so the prediction is, it won't be a accurate prediction. Okay, there will be a lot of problems will be there. It will always provide a wrong prediction. So we need to analyze the data, and then we have to find the errors, and then we have to fix it. Then only we can just feed that into machine learning models. So for that, what kind of uh, libraries we can use for that? Okay, so whatever it is, if we are just getting into machine learning or deep learning concept, first of all we need to be good in Python. We have to learn the advanced level of Python. It's not like the basics. We have to get into the Python. We have to get trained from that. Then only we can understand the patterns to do the machine learning concept. So mostly why we can only you can use Python only if somebody is asking about that. That is not a proper answer for that. You can work on anything actually. Now we are using Python because Python has a lot of library support. Okay, but other programming language, if you're just getting into our language, from our language also you can just do the same thing. From Java, from core Java also can be used for machine learning or deep learning concept. Okay, but that is like there we won't get that much library support. But Python has a huge community. There is a lot of library support is there. So that thing we have to. So that's why we are just looking this. Yeah.
ঠিক আছে সেটা ডেটা দুটো ডেটা আছে দুটো লিখে দেবো আমার লাগ
Okay. So okay. So libraries for geospatial analysis. Okay, what kind of libraries can be used for the geospatial analysis? Because we are going to handle the GIS data, spatial data, I mean. So those data can be handled. You can see here, the polygon data is plotted on this map. So I'll get all the entire India, all the districts are there. You can see that is we are getting the legend also. It is an interactive map. By clicking also, you can just see which places are from which areas. This everything can be done via open source library file, that is GeoPandas. So I'm talking from Bangalore. So you can see here, it's the Bangalore data. It's a very efficient library. We can use it for vector data analysis. Then we saw another. It is a I gave that as a state. Okay, state data. So there is another thing is there. There is a district data also there. So now we are going to explore the district data. Each district has a different colors, and then it is just getting the entire India's district segmentation. So now we will explore that also. And when we explore, it will just plot it like mark it on the map, and then it will visualize that for us. There's a lot of data there. I mean, how many districts are there in India? So that's why it's just taking a little time to load. You can see all the districts are separated. And then it's just marked on this interactive map. This kind of analysis, for this analysis, we don't need any software. We can simply do that with Python and the open source library. So if it is a vector data, of course, we should choose GeoPandas. Just GeoPandas is enough to do these things. Okay. So now we understood like how the geopandas can be used for vector data analysis. Then there is another thing is there. What is raster data? So raster view is a raster data classification image. From that we can just check the things. I'll show you another example for that also. So here I can see, but this data is like a very huge data. So the around 4 or 5 GB data. So here you can see I'm just importing the RAStudio library, then I just giving the path for the file. So we are just currently working on a project, and then related to that I just made this classification. So here you can see, so it is the forest area occurred in Bangalore. So here I just doing the analysis things by using this RAStudio. Okay, so you can just change the color things. You can see the green area by changing the uh, image projection. You can see there's a pink map. So in this way, you can just take the raster images and then you can just analyze that, and then you can just make the predictions. Okay, you can change the projection system also. If you want to plot it on the map, from that you have to call the same JPandas vector. I mean, so if you want to make an interactive map and then you have to paste the things there, from that also we have to use the JPandas library. You can call the map and then you can utilize the things here itself. So we don't need any other software to analyze the things. So Python is very powerful in that. So we will get a lot of library support. Through the library support, we can do everything for free. So that is the main thing. So then I already talked about the things. So what is machine learning? We're just coming from there again. Some supervised learning was there. So for example, in supervised learning, you can say linear regression and support data machine, then k nearest neighbor algorithm. So there are various number of algorithms are there. So I'll just show you some examples what I have done recent days. You can start from this decision trees. Okay, so for that we are using some libraries, that is pandas. The pandas are using to handle the tabular column format data. For example, if you have a row and column data, so the data is here. What I'm using is this is the data. I'll show you. The data is like this. It's a kind of rainfall data. Okay, so what we are going to do, we are going to predict there is a landslide possibility is there or not. Okay, I didn't give much data because uh, we are just increasing the data, then it will be a good model. So I'm just giving an example. That's why I just gave a small number of data. You can see. So here you can see there is a rainfall is there. The rainfall example, that is VH means very high, H means high, A means average, then it is low, it is very low. Then soil type. Soil type is clay, sandy, loamy, mud. These are the data. Then altitude. So what is the altitude of the things? Then it is just defined by out of 10. If it is high, that is 9. If it is the altitude 10, that is 3 or 5. Then there is any construction thing is happening around the area or not. Okay, if it is a hill place, if there anybody is building any building or any construction is going on, that we are defining yes or no question. It is a binary question. Then we are mentioning that is landslide happened or not. So these are previous data. Okay, there is a place there the rainfall is very high. There is the soil type was clay. Then the altitude was 9. That was the high. Construction also happened there. So there is a landslide happen. So here you can see this yes or no, the last one, the landslide column is there. No? This data is the dependent variable, we will say. Dependent variable means this is the things what we are going to predict. Okay, from the these data. So these data are independent data. It can be anything, but this dependent data is depending on these other data. Okay, so by changing this output also will be changed. Okay, but it won't affect anything more than that. Okay, those are independent data. It can be anything, but whatever is changing, it will affect the final output, the landslide. Okay, that is the main thing. So in everything, if it is a supervised learning, it is an example for supervised learning in machine learning. So if it is a supervised learning, of course there will be a dependent variable and independent variable. Okay, so we'll come to the program now. So now you can see that is in that format. So there the data is separated by comma. So that's why it's called as CSV file. In the CSV file, it will look like a kind of Excel image, Excel data you can consider. So in this we have a data that has row and column. Okay, I'm just getting the data, reading that, and then just converting that into pandas format. Then I'm just printing the pandas format data. You can see now it is the pandas format data. So you can see automatically it just gave the index number for that. And then if it is rainfall is very high, the clay data type, clay soil type is there, and the altitude also 9. Construction is going on, yes. Then the landslide happened. No, here you can see construction happened. Altitude is 6. Soil type is loamy. Rainfall is average. So depend on that, this final value, it is the dependent variable that is changing. Okay, so if you're just changing the value, this thing can be affected by this value. So these 4 columns: rainfall, soil type, altitude, construction, these are independent variable. This is dependent variable. So we are going to predict this only. Okay, so we will get the data of rainfall and soil type and altitude and construction, everything will get. From that we will predict there will be a landslide will happen or not. That is what we are going to predict now. Okay, then I just giving other again importing the pandas and then just giving the data and then converting that into geo like pandas format and just giving the df. Here you can see the problem is when we are just getting into programs there the letters won't work. I mean the string data won't work. We need the data that should be in numbers. Okay, so there we can't use the data like this bl l a like that. So for that what I'm doing is I'm going to convert the value into like values. So this is data analysis process. Okay, this is the way how we are going to extract the features. So if it is very low, I'm assigning the that is 0. If it is very high, that is 4. You can see here. Okay, the rainfall data is there now. Here we have bh hal like this. What I gave us, this is if it is very low that I gave us 0. If it is very high, that is 4. So depend on the values, I just change this variables. Okay, but in the rainfall I'm just going to change this. So after changing that, you are just seeing the changes here. The rainfall is changed like this. Here there was bh, now it became 4. So it is very high. Here you can say 0, that means very low. Okay, then just giving soil type also. Soil type, if it is a clay, that is 0, loamy is 1, mud is 2, sandy is 3. So in that way I just changing the value into soil type also I changed. Altitude was already in numbers, that's why I'm not touching that. Here you can see construction and landslide, yes or no question. It is like a binary question. We already know it's a, just consider like as a gates, like how we are using and and nor gate. Multiple gates are right, and gate, not gate, and or gate. So those will give true or false. The same thing. If it is true, that means 1. If it is false, that means 0. The same thing. I just taking this construction and landslide values, yes or no. If it is yes, that is 1. If it is no, that is 0. I just assign for everything. Now here you can see we are getting the proper data. So now we just extracted the features here. Okay, this is how it works. Then the next line, what I'm doing is, you can see I'm just giving the features. Features are rainfall, soil type, altitude, and construction. These are the features. The independent variables are the features. This thing, the landslide, is the final output we will get. Okay, so I'm just giving that C. In X, I'm giving this feature, and in Y, I'm giving these features. Okay, I just separated the things. Here it is that, here it is that. It is a landslide. This is the index value for both things. This is not data, it is index value. These 4 things are separated. The last one, the output is separated. Then I just going to give that in a machine learning model. For that, what we are going to use it, that is sklearn. Sklearn means scikit-learn. So there we will get a lot of library support for all the machine learning and deep learning concepts. Okay, that's why we are choosing Python for machine learning. Why we are choosing that question is rising, right? Just because of this only. You will get this kind of pandas library, sklearn, and matplotlib for plotting and visualizing the things. So what is doing? What is doing? What exactly library? So before getting into that, we have to understand what is library. Library files are the program file, same Python program file. Okay, we don't have to program everything here. Okay, so there might be there is a developer is there, there is a developer community is there. The developers developed something, developed multiple algorithms and then they just store that inside this kind of library file. The library files are stored in a community page. We can literally can install that, and then we can utilize the programs whatever they have written inside the libraries. Okay, here pandas, sklearn, everything is the Python files only. Those Python files contain some functions. Those functions will be there inside the library file. We will import this inside our code. Then we will call that program directly here. This is what people are saying as library. Okay, libraries are modules, people will say. So we can see I'm just importing that sklearn. From the sklearn, I'm just importing tree separately and decision classifier and this matplotlib I'm just importing in my code, and then I'm just going to create a decision tree from that. Decision tree is a method, machine learning method to make predictions. How it is declaring? I'm just making a extracted data from there. So this is in X. X is this data, the 4 data. Y is the output data. I'm just giving that inside this model. Decision tree, I'm just giving the fit. You can see the decision tree is directly I'm calling. It is located inside this sklearn module. So I'm just calling it and just giving the data. So then I'm going to plot it as a decision tree. You can see the decision tree, it will make like this according to our data, whatever we have given. So through that, it just made this decision tree inside the. So I just visualizing that how it is working. So now what we're going to do, I'm just giving the data for this, and then we are going to give the prediction. You can see d3.predict. I'm giving 0. This 0 for the rain value. It is 0 means it is very low. There the rain like very low rain is only happened. So I gave 0. Then the second data is the soil type. Soil type I gave 3. 3 means you can see 3 means sandy. Then altitude, then construction is happening or not. That is what I gave like this. So that is the altitude is 8. There is no construction is happening. I gave this data and then I just giving that and then just getting the output. We are getting the output as no possibility. Now it is a machine learning model. Okay, now it is the final output. You can consider as A also. Now I gave some data. So here there is very less rain, but there is the soil type is sandy. There is the altitude is 8, but there is no construction is going on. Like that I'm giving. So now it is just giving no possibility. Okay, from that data, the machine learning model learn from our data, whatever data I have given, but I didn't give that much data. For example, I just made a very small data, and then I just ran this. So now it is I'm giving 4. 4 is like very high rain is happening there. Then the soil type is same. Like the soil type is same sandy only. I'm just giving the altitude as 8 only. I'm not changing anything. So I'm just giving the construction is not going on. You can see the output is changing now. There is a landslide possibility now. I just changed only one variable. That's why I told you that is this is a dependent variable. So the dependent variables are changing the these are independent variables that is implementing the dependent variables. The dependent variable will be the output for us. The output is we are getting 0 or 1 here or not. So the final output for this landslide, these are independent variable, right? We are changing the independent variable because this dependent variable is depending on other independent variable. So I just changed to only one value here. So now it is just showing there is a landslide possibility. Okay, this machine learning model is developed in this way. I hope you understood the concept now. Okay, there are a lot of algorithms are there. In our classes, we are teaching 5 or 6 algorithms, how it is working, then what is the path, what is feature, how we can just choose the models and everything we are just defining here. So from that, we are just machine learning model or any AI or something like that. Okay. Okay, So in GIS, what are the things users can be done? So the main things, environment monitoring. I just gave an example for this only. So environment monitoring. So AI techniques such as machine learning enhance the analysis of environment data and aid in monitoring changes over time. Okay, we can continuously monitor the things and then we can get the real-time data. So a person don't have to sit there and then monitor the things every day. He doesn't have to do any process analysis and then give the output for us. Okay, these AI techniques will automatically get the data and then it just find the problems and then it will give us the solution for that. Okay, that is the environment monitoring. The next one is urban planning. AI plays a critical role in urban planning, optimizing spatial distribution and suggesting sustainable and development initiatives. So what is urban planning? If I just the urban place is there are a lot of things are developing, right? For example, if there is a new state is like creating and then there is a capital is there. For example, in that time we can say uh, Andhra Pradesh. Okay, for example, consider like Andhra Pradesh. Previously, Andhra Pradesh and Telangana was merged together. So at that time, they had only one capital, that is Hyderabad. Okay, so now Telangana took Hyderabad. So Hyderabad is being as capital of Telangana. Now Andhra Pradesh actually they didn't allow any capital for Andhra Pradesh now. Okay, they are planning for like Vijayawada and Nellore. So one more thing is there. Tripadi also can be a possibility is there. So now they are planning which is the best one, how they will find and then how they will make a capital. Okay, so for that they have to analyze the data. Okay, so which place will be the best for everyone, like as being a capital. So if they are just announcing the Vijayawada, it's a kind of coastal area, so the like it will be good for the people or not. So everything they have to collect all the data and then they have to find the insights of the data. Then they have to make the decision. For us, I'm just giving an example, real-time example. For that, if you're just creating an AI, so if you're just feeding the data, from that it will help us to make the decisions. Okay, so from that, if we are just giving the satellite image or spatial data, it will just analyze the entire data in this way, and then like which data is developed well, so which data has enough space for just even every places, all the places has an airport. Okay, but if it is a capital, there should be an international airport should be there. Okay, that should be like a lot of planes will come and go every day, and every day there is a business head of the entire state. So a lot of process will happen, so lots of transportation will be there. So which place will be the best place as being as a capital? For that also they can use the AI to just do the analysis and then just make the prediction. That is for urban planning. So disaster response. Now I just talked about the landsliding thing. I just showed you an example there. So that is you can consider as a disaster response. So due to the like we are just if we are having enough sensor and all, so we can just continuously monitor the weather and these kind of things. If it is a hill station, there they have to call like monitor all the data day by day. So depending on the climate, and then if it is raining, so any human intrusion or they are just cutting the tree, all the data can be uh, like collected and then calculated. So after doing the analysis, we can just make a model and then it will predict and then it will just give the response for us. Okay, I'll give you some more example like this. So that I showed you there is a decision tree is there. So there will be another thing I can say, uh, support error mission. I'll show, yeah, k nearest neighbor algorithms. So here what we are going to do, so we are giving the weather data. So now we are going to find there will be rain tomorrow or not. Okay, so this is also a similar data, but I have more data here. So I told you it's depend on the quality and quantity of the data. So I just giving the simple example for this. From that we will make the weather prediction. Okay, so I'm just giving, you can see NumPy. So what is NumPy? NumPy is also a library, so which can be used in Python. So when we are handling the like big volumes of data, so if we have more than 1,000 data, if we are just handling those kind of data, that time Python has some inbuilt data like array data type. For example, uh, list, tuple, set, dictionaries, those things are there. But those are not faster than NumPy. Why NumPy is faster than, why we are using a, like kind of, it is not a inbuilt data type, it is a external data type. We are just calling and then we are just using that in our Python program. So why we are using that means because NumPy is developed by C language. The entire module NumPy library is developed by C language. The C language is like it is just taking less memory, and then this computational time is very fast. It is faster than our Python inbuilt data types. So the NumPy is 40 times, 40, literally 40 times faster than our Python inbuilt data type. That's why we are using NumPy for our classification. So all the data will be converted into NumPy or Panda format. After that, it will be used in our program. So because we are using numerous number of data, like volumes of data, big volume of data we are using, that time all the data will be converted into this kind of NumPy array data type. Then we can utilize that in our program. So it will work faster than usual. So you can see matplotlib, pandas. Then I'm just using the same sklearn for the k nearest neighbor algorithm. So I'm going to call the algorithm from there, and then I'm just going to show the intersect of the things. The same way, I'm just reading the file. This file is there, metadata.csv format here. Okay, it's a simple data. So it is for support data machine. Yeah, here. Okay, this data. From there, I'm just going to make the predictions. Okay, so the weather data is how it's looking. You can see the outlook is sunny. Then the temperature is there. It is like in Fahrenheit. It is not in Celsius. So don't think like it is 85 degrees Celsius. It is in Fahrenheit. Then the humidity in the air. Then it's windy or not. The rain tomorrow or not. Okay, these are the past data. How we collected. There has 141 rows and 5 columns. 1, 2, 3, 4, 5 columns are there. 0 to 140 rows are there inside the file. That is what it's showing. So we are just taking the same way what we used to do. The same way we have to convert the data into like numbers data, because those are in text data, right? So we are just converting them into true or false, and then we are just going to make the predictions. So it is just making the confusion matrix. Wait, I'll show you in this, then you will understand more. Okay, so all the data will be converted into numbers data. Then after that, this is what is actual, what is this confusion matrix? Okay, so whenever we are going to train a machine learning model, that time we will separate the data into two sets, data set. If you have 100 data, then we will take 70 or 80 data for training, 20 or 30% of data for testing. So here I just took around 70% of data for training. Okay, here test size is 0.3. It means 30% data for test. So 70% data for training. So I just gave the 70% data for training, and then I trained the model. After that, we have to validate the model. The model is working well or not. It is working properly or not. It has any issue or not. I have to find that. For that, I have to test the model. For that, I separated the data, right? So I separated the 70 data for training, and then I separated the 30 data for training. I just gave that together, and then from the built model, I just giving the 30 data as a test data, and then testing with each other. Okay, the 30% data is checking with that, and then the 30% data already have the output. Okay, these data also taken from that same data set. That is also have, there is a rain tomorrow possibility is there or not. We know that. So from that it's checking the actual negative is there will be no rain. This is predictive positive is there will be a rain. Okay, that is the thing. These are the wrong predictions. So comparatively, this active negative and predictive positive, those things should be high. If it is high, the like the model is working well. These things are high, then the model is making more wrong predictions. That is the thing. So now it made 124 right predictions. Here 117 right predictions in rain, no rain, both. So this is some values there won't be any rain. Then also it told like there is a rain, but there is a wrong prediction. So there will be some rains weather, but here it is predicted like there is no rain. So that is a wrong prediction. So these are the wrong prediction. The actual wrong prediction value you can see 59 is there, but here it is more than 200. Okay, around 40 something. Yeah, 240 something. That much right prediction is there. Comparatively, this right prediction is more than the wrong prediction. Of course, the model is working well. So after that, we will find this receiver operators accuracy. It is like how the accuracy is improving, how the accuracy is decreasing. That is the way how to find it. So then I just doing that with a different data set, and then I just checking that again and again. So to make the model, find the model it is working well or not. I'm just giving the different data and then checking with that. So I'm just giving the similar result again and again. So finally we can come to the conclusion that is the model is working fine. So that's making most of the right predictions. So through that we can just make the model like more effective. Okay, so this is the machine learning model with developed with k nearest neighbor algorithm. Okay, this is how it works. Okay, guys. So it is the end of the session. So I hope you understood of machine learning and deep learning concept, then how we can just integrate the GIS concept in that, enough data we can use in this, and then how we can handle the data with the libraries. That also we saw that if it is a vector data, we can use the GeoPandas library. If it is a raster data, we can use the Rastrio, and then so the entire session we just understood the overview of the entire concept, right? Okay. So I hope my team people are just talking in this comment box. Yeah, so this is going well. So if you have more interest, then you can just contact us. So I can just join the class. So we have Python. Also, if you don't know about the Python, then also you don't have to worry about that. You can join for Python classes. There you will learn about Python, the entire Python
Can we
system.
get your number, sir?
What?
Can we get number, sir? Phone number,
Yeah,
sir?
you can get the contact details in this comment session, right? So in this call message, you will get everything, right? So that you can get it. You can just contact us through the website here. I hope it's visible. So it is our website, the LinkedIn profile. So you can contact Mr. Vijay. So he is the person who is just handling all the things. Who is the person who is just arranging this webinar also. I'm really thanking Mr. Vijay. So and Noor also. So it's went well, I hope. So if you have any other doubts and all, you can just contact them. You can just contact through this website also. If you have any queries, you can just contact Mr. Vijay. Okay. Okay, if you have any doubts, you can just raise your hand and then you can just check in the in-call message. I will reply for that. Okay, Ajay Singh, what is your query? You can ask me.
Yes, basically, my question is how to create this CSV file from a satellite images.
Like, actually, I'm sorry, your voice is very low. Can you speak louder?
How to create this CSV file
Okay.
from the satellite images.
These CSV files are the real-time data, which is just already collected from the field actually. So there is already some things that happen. Some I told you we are. It is a supervised learning concept there. So some places had some landslide issues. From there, they after the landslide, actually they just went and then they just collected the field data. Okay, so what are the things are the like causes of the landslide we are checking? So there the rainfall is happened. The rainfall was very